Hello, welcome back. And I'm going to talk today about how to graph the rational function. Graphing the rational function has several steps. So we have to know these steps. First of all, we have learned about vertical asymptotes, horizontal asymptotes, and right before we learn about how to get X and Y intercepts. Today, we're going to use all of these together in graphing the rational function. One more thing that we have to know is whether the rational function crosses or does not cross the horizontal asymptotes. In order to know that, I'm going to go to my favorite function is 1 over x and see whether this function crosses or does not cross the horizontal asymptotes. So let's go to the share screen. Go down here, and then here. Okay, so based on what we talked about, that sometimes, not all the time, that the function can cross the horizontal line. If I say that example, f of x is 1 over x, when I graph this function, the horizontal asymptote is y equals 0 here. So you see that the function does not cross the horizontal asymptote. But sometimes the function could cross the horizontal asymptote like that. Not 1 over x, but we could have a different function. Oops. We have a different function that goes this way. So you see that it crosses the horizontal asymptote at a certain point. The question is how to test whether the function crosses or not crossing the horizontal asymptote. In order to do that, I have to give another example that shows that the function cross or doesn't cross the horizontal asymptote. So let's get that example. I have f of x is x squared minus 3x minus 2 over x squared plus 1. The first step, step 1, find the horizontal asymptote. I can't tell whether the function crosses the horizontal asymptote or not unless if I find the horizontal asymptote. By the way, I have to tell you something here, that this rule is applied on the slant asymptotes. I'm going to give you 3 examples of graphing the functions, and you see that this rule works also with slant asymptote. So here, based on the rules and based on what we learned, the degree of p of x is 2, and the degree of q of x equal 2. Therefore, y, the horizontal asymptote, is the leading coefficient of p of x divided by the leading coefficient of q of x. So y equals 1, and the leading coefficient of the denominator is 1. Therefore, the horizontal asymptote is y equal 1. Okay? Now, if I want, let's go back here. If I want to see whether the function across the horizontal asymptote, in this way, I have to find this point, which is the x value. So I want to find the x value here that makes the function cross y equals 0. In this way, to find the x value, I set y to 0, or y to the value of the horizontal asymptote. So here in my example, y equals 1. So in order to find the x value where the function crosses the asymptote, I have to set the function to 1. Okay, so let's do that. So x squared minus 3x minus 2 over x squared plus 1 equals 1. We multiply both sides by x squared plus 1. So I'll get the answer. This canceled out. Now get here x squared minus 3x minus 2. And 1 times x squared plus 1 is x squared plus 1. All right. Let's simplify this. I see here is x squared and x squared on both sides, so I can cancel x squared minus x squared. So I have negative 3x minus 2 equals 1. Okay, add 2 for both sides. So I have negative 3x, 2 is negative 2 is canceled out, equals 3. Divide by negative 3, I have x equals negative 1. Okay, so now what does x is negative 1 means? That means that the function crosses the y, y is equals 1, which is the horizontal asymptote at the point x equal 1, x equal negative 1. So the point negative 1 and 1 is where the function crosses the horizontal asymptote y equals 1. Okay? So now this is how we test whether the function crosses the horizontal asymptote or not. Now, based on this step, we will learn how to graph the function. And this is the extra step that we didn't know. But now we know X-intercept, Y-intercept, vertical asymptote, horizontal asymptote, and how we check whether the function crosses the horizontal asymptote or not. Okay, let's go to the steps. We have 5 steps here to graph the function. So the function f of x equals p of x over q of x. In order to graph this function, I have to do 5 steps. Number 1, and it's already on your notes, I need to find x-intercept and y-intercept. Number 2, find the vertical asymptote. Okay. Number 3, the horizontal asymptote or slant asymptote. Number 4, and this is that we learned before, is to test whether the function crosses the horizontal asymptotes or the slant asymptotes. Let's say or the slant asymptotes. And number 5 is the plot the points, plot the X-intercept and the vertical asymptotes points on x-axis, and we're gonna use these in graphing the function. Okay, so let's start. I may need an extra one. Let's see. Maybe I need a new notebook. And we need dotted one. And create. Yeah, so that would be better. All right, well, let's see how that goes. So I have example number 10. Graph a function f of x equal to x minus 6 divided by x plus 2. All right, so here is the idea is follow the first steps. This step 1 is find x and y intercepts. Okay, x-intercept, set f of x to 0 and find the value of x. So if y 0, f of x equals 0, so 2x, let's write this down here. So x-intercept (2x minus 6 over x plus 2 equals 0. So we multiply both sides here by x plus 2. So we multiply this by x plus 2 times x plus 2. Differently, anything multiplied by 0, 0. And here's x plus 2 with x plus 2 is cancelled out. So I have 2x minus 6 equals 0. 2x add 6, 2x equals 6. Divide by 2, I get x equals 3. So therefore, my x-intercept is 3 and 0. Okay, y-intercept. Y-intercept, I set x to 0 and solve for y. So I have 2, which is f of 0. Now let's write it down here. So I have f of 0 equal 2 times 0 minus 6 divided by 0 plus 2. So 2 times 0 is 0, so I have negative 6 divided by 2, which is negative 3. So I have y-intercept is 0 and negative 3. Okay, so I got x-intercept, and here is y-intercept. Remember that I have to write the vertical asymptote and x-intercept on the number line. Okay, so now I got x-intercept and y-intercept. Step 2, find the vertical asymptote. Okay, when we do the vertical asymptote, we set q of x is 0, which is x plus 2 equals 0. So that when I solve it, it subtracts 2 I have x is -2. So this is my vertical asymptote. 3, find the horizontal asymptote or the slant asymptote. So now we look at the function again. I have the degree of the numerator is 1 and the degree of the denominator is 1 as well. So the degree of p of x equal the degree of q of x equal 1. So therefore, y equals the leading coefficient of p of x divided by the leading coefficient of q of x. So what's the leading coefficient of p of x? It's 2 divided by 1. So I have y equal 2 divided by 1. Therefore, y equals 2. So this is the horizontal asymptotes. Let's do this in, and this is the vertical asymptote. And I have X-Intercept and Y-Intercept. It's clear so far? All right. The next step is to find whether the function crosses the horizontal asymptote, which is y equals 2 here. So in order to do that, I set the function to the value of y here, which is 2, and see if I have x value or a false statement. So let's see. So I have 2 x, the function, minus 6 over x plus 2, and I set this to 2 and solve for x. Okay, so I multiply both sides by x plus 2 times x plus 2. Simplify. So I have 2x minus 6 equal 2 times x is 2x, and 2 times 2 is 4x, is just 4. Okay, subtract 2x, so I got -6 equals 4. This is not a true statement. So therefore, since I got a false statement, that means that the function does not cross the horizontal asymptote. Okay? Okay, now I'm going to test the values here, and let's do that in another page. Test the values, and we see where is positive and where is negative. So the first step I do is to graph a number line and plug the points of the vertical asymptote and X-intercept. So I have the vertical asymptote is -2. Let's go back here. I have the vertical asymptote is -2 here. And I have X-intercept is 3. So I'm going to plug on the line -2 and 3. So -2, and here is 3. Okay. Now we test the function before -2, from -2 to 3, and from 3 to infinity. We plug any value here, any number, for example, -1, and we check whether the function is positive or negative. So all I need to do to test whether the function here is positive or negative Similarly here, positive or negative, and then the third interval, whether it's positive or negative. So let's write down the function again. I have f of x is 2x minus 6 over x plus 2. All right, so let's plug anything less than negative 2. So let's say negative 3. So f of negative 3 equal 2 times negative 3 minus 6 divided by negative 3 plus 2. And if I simplify that, so 2 times negative 3 is negative 6, and then negative 6 divided by negative 3 plus 2 is negative 1. So I will get negative 12 over negative 1, which is 12, which is positive. So here, below negative 2 is positive. Let's write that down in red. Now we tested the second interval, and obviously the best or the easiest number between negative 2 and 3 is 0. So f of 0 is 2 times 0 minus 6 divided by 0 plus 2. So 2 times 0 is 0, so I get negative 6 divided by 2, which is negative 3. And negative 3 is negative. So here is everything is negative in this interval. Okay? Now, let's test the third one. So if you give me any value that is greater than 3, the first one that comes to my mind is 4. So 2 times 4 minus 6 divided by 4 plus 2. So I have here 8 minus 6 divided by 6. So I have 2 over 6, which is 1/3 positive. So I have this area is positive. Okay, so far? So now it's time to graph the function. The first step to graph the function is to plot X-intercepts and the vertical asymptotes. Let's do that first. So perhaps I have to be careful here. All right, so let's make a big one. Okay, and now I have X-intercept. X-intercept is 3 and 0, and the vertical asymptote is y equals 2. Excuse me, y equal 2. So I have to plug 2 and I have to plug 2. Oh, I'm sorry, that's the vertical asymptote here is negative 2, and X-intercept is 3. So I have to plug 3 and negative 2. Okay. So the vertical asymptote is Oh, so here is x is 3 and 0. Vertical asymptote is x equal -2. So I'm going to go here and plug -2. So this is -1. And here is -2. And also I have 3. So 1, 2, 3. Okay. And now I will shade a dot line -2. Okay. So this is the first step I do. The second step is to find X-intercept and Y-intercept. So I have X-intercept is the 3 here. Let's make this blue. And Y-intercept I got from the back. Y-intercept is 0 and -3. So I go to -3 here. 1, 2, 3, -3. And I do this point. And also the other point is graph the horizontal asymptote. Horizontal asymptote is, okay, here is the horizontal asymptote is y equal 2. All right, so let's graph the horizontal asymptote. This is 1, 2, now let's write this down. This is y equals 2, and this is x equal -2. Okay, now the function doesn't cross, the function based on the test does not cross the horizontal asymptote. So the function cannot be here. So it must be down below x equal 2. And it goes with x-intercept and y-intercept. In other words, that the function would go this way. Maybe you need to add more that line. And now we're going to graph the function. So I graph this function that way based on what I have here. I have from 0 to 3, or sorry, from 3 to infinity is positive. So it must be here positive. And then below 3 here, that would be negative and passes through this point and goes close to the vertical asymptote. So let's see that. So here, I graph it by green. So I graph it from here. And then passes through that way, maybe a little more. So this is the first part of the function. Okay, so I graph it here because positive from 3 to infinity, here is positive. And from -2 to 3 is a negative. But now from -2 to infinity, or to negative infinity, is positive. So I'm going to go here and make this positive. But here's a question. Where should I put the positive? Will it be here, down, or there? It must be here because it's positive, okay? And also because I learned from this function that it does not cross the horizontal asymptote, therefore the function must be here. And then I graph the function. like that. So here's my function. So let's start to talk about the steps. So step 1, I compute x-axis, I compute X-intercept, Y-intercept. Step 2, I compute the vertical asymptote. Step 3, compute horizontal asymptote or slant asymptote. Step 4, test whether the function crosses the horizontal line or not. And the following step would be is to test the positive and negative negative area or negative interval, and that helps me to graph the function. And the last step is to find if the function crosses or does not cross the horizontal line. And then we graph the function. Okay, I hope that this helps. However, I'm going to give you another example so that helps developing the idea of graphing the function. So let's do this function. I have here f of x or g of x equal x squared plus 3x minus 4 over x squared minus 2x minus 8. Okay, the first step is to compute x-intercept. X-intercept, we set the function to 0 and solve for x. So I have x squared plus 3x minus 4 over x squared minus 2x minus 8 equals 0. I multiply both sides by the denominator, x squared minus 2x minus 8, and here is x squared minus 2x minus 8. Of course, this is 0, and the denominator with x squared minus 2x minus 8 is cancelled out, so I have x squared plus 3x minus 4 equals 0. This is quadratic equation. We factor and solve for x. So I have x, negative 4 give me 3 positive, so that would be plus 4 and minus 1. So here's x is negative 4 and x is 1, and this is equal 0. Okay, so now how many x-intercept points? I have 2 x-intercept points. So I write them down, negative 4 and 0 and 1 and 0. Similarly, I compute y-intercept, which is f of 0 is equal 0 squared plus 3 of 0 minus 4 over 0 squared minus 2 times 0 minus 8. So 0, 0, 0, 0, I get negative 4. And here is 0 squared is 0, minus 2 times 0, 0, over negative 8. Negative 4 over negative 8 is 1/2. Therefore, y-intercept is 0 and 1/2. Okay? Now, the vertical asymptote. What is the vertical asymptote? We set the denominator to 0, and we find how many vertical asymptotes I have. So basically here, when I set x squared minus 2x minus 8 equals 0, I have to factor again. So I have x minus 2, x plus 2 times x minus 4 equals 0. And now I have two values of x. I have x is -2 and x is 4. So now how many vertical asymptotes I have? I have 2. I have -4 and 4. So basically right now I have how many points I have to put on the number line. I have -2, I have 4, and also X-intercept, which is -4 and 1. So how many points? 1, 2, 3, 4. So I have to plug 4 points on the number line. In other words, I have to test, I think 6 intervals, 5 intervals. Okay, let's see. So I computed the vertical asymptote. So what about the horizontal asymptote? So I would check, I have g of x is x squared plus 3x minus 4 divided by x squared minus 2x minus 8. So notice here that the degree is the same. So, and the leading coefficient here, so I use the leading coefficient, I have 1/1. So here, the horizontal asymptote is y equals the leading coefficient of p of x divided by the leading coefficient of q of x, which is 1/1 equals 1. Therefore, the horizontal asymptote is y equal 1. Okay, so 2 vertical asymptotes and 1 horizontal asymptotes. Now the next step is to test the function, whether it crosses the horizontal asymptotes or not. In order to do that, we set the function to 1, which is the value of y, and then check whether I get a value of x or a false statement. So let's try that. So again, my function is x squared. So let's say here, test crossing. So x squared plus 3x minus 4 over x squared minus 2x minus 8 equals 1. And so for x. So we multiply both sides by x squared minus 2x minus 8, x squared minus 2x minus 8. So here's canceled out. So I have in the left side x squared plus 3x minus 4 equals 1 times the product. So I get x squared minus 2x minus 8. Again, x squared and x squared, subtract x squared. So I have 3x minus 4 equals negative 2x minus 8. We add 2x, and here we add 4. We add 4. So I have here 5x and negative 4 with positive 4 is cancelled out, equal 4 minus 8 is negative 4. Therefore, when divided by 5, both sides, I get x equal negative 4 over 5. So what does that mean? That means that the function crosses the horizontal asymptote y equals 1 at the point negative 4 and 5 and 1. So the point of crossing is negative 4 and 5 and 1. Okay, so this is a point of crossing. All right, now I need to test the function and then graph the function. So let's go with this, the last step in testing. Let me test the function here. Okay, so I have how many points? I have 4 points. So let's see if I have 0 here. I have 4 points. I have negative 4 and negative 2. So let's see. I have for the X-intercept first. I have negative 4 and 1. I have 0, 1, 2, 3, negative 4. And 1. Here is 1. And I have, for the vertical asymptotes, I have negative 2. The vertical asymptotes here. Negative 2 and 4. Negative 2. And 2, 3, 4. Okay, let's test f of anything below the test here. So we'll try below negative 4. So we will try f of negative 5. So what if I try f of negative 5? So I'll have my function here is negative 5. Let's try the function here, negative 5 squared plus 3 times negative 5 minus 4 divided by negative 5 squared minus 2 times negative 5 minus 8. Okay, simply this is 25 minus 15 minus 4 divided by 25. And here is a negative times negative is positive 10 minus 8. 25 minus 15 is 10. 10 minus 4 is 6. 6 divided by 25, 35 minus 8 is 27. Therefore, this is a positive. So from here, I have positive. From negative 4 and negative 2, I'll get negative 1. So f of negative 1 is equal negative 1 squared plus 3 times negative 1 minus 4 over negative 1 squared times 2 times negative 1 minus 8. So I'll get in the top 1 minus 3 minus 4. On the bottom, I have 1 plus 2 minus 8. And I have here negative 7 minus 1 is negative 7 minus 1 is plus 1 is negative 6 divided by negative 5. Okay, that's the second. Negative 2 and negative 1 squared minus 3 I think that there is something incorrect, so let's try that. So -2 and 1, let's try 0. I think 0 would be easier than that. So f of 0 is 0 squared. Okay, I think I have write the function wrongly. No. Oh, I see. Okay, I see the point. I think I skipped -3. So I need a point here, and I skipped -3. So this is f of -3. I need, I combined these two intervals actually, so that was the problem. So I have another interval here, and interval here, one interval and one interval. So 1, 2, 3, 4, 5. So from -4 and -2, I will plug -3. So f of -3 is -3 squared plus 3 times -3 minus 4 over -3 squared minus 2 times -3 minus 8. Okay? So -3 squared is 9 minus 9 minus 4 over 9 plus 6 minus 8. So 9 minus 9 is 0, so I have -4 on the top. And 6 plus 9 is 15, minus 8 is 7. So -4 over 7 is negative. Yeah, this is correct. Here is negative. And now I have the one that I solved before, f of -1, and I think I got f of -1 is a positive. So f of -1 is -1 squared plus 3 times the -1 minus 4 over -1 squared minus 2 times -1 minus 8. So I have -1 squared is 1 minus 3 minus 4 over 1 plus 2 minus 8. So I have here -7 plus 1 is -6 over 3 minus 8 is -5, which is positive. Okay, so I have here's the area. This one is positive. Okay, from 1 to 4, I'll choose 2. Oh, by the way, I can choose 0 here. Here's from 1 to 4, I'll choose 2. So f of 2 is 2 squared plus 3 times 2 minus 4 over 2 squared minus 2 times 2 minus 8. And if you compute that, I will got a -1, a negative. And for the last one, or 4, maybe f I'll take f of 5 And if you compute it, you would get positive. This negative and this positive. I'm just going for the time being to be short, but you know how to do that. So here it would be positive. Okay. Too many intervals actually in this problem, so it takes time. And to be honest, I'm not gonna give you in the exam a long one, but I want you to know how to solve this problem. Okay, let's graph this function. So what I need in graphing is to answer these questions. Number one, here, X-intercept. And I got for this one, X-intercept, I have X, I need the value, X is -2. Oops. I have X is 1 and X is 4. Y-intercept, I have Y is 1/2. I just need the values here, so it's not the point. And I have the vertical asymptotes. X is -2 and X, I think, I'm sorry, this is -4 and this is 4. And the horizontal asymptotes, I have Y is 1. Let's double check here again. So I have -4 and 1 for X-intercept, -4 and 1. And for Y-intercept, I have Y is 1/2. Vertical asymptote is -2 and 4. Horizontal asymptote, Y equals 1. And at the crossing point here, the crossing point is -4/5 and 1. All right. So I started by graphing the coordinates and then plot X and the vertical asymptote and the horizontal asymptotes. So let's start by that. Maybe I need the rest of this one. Right? So if this goes to 4, I'll make this 1, 2, 3, 4, and I have minimum 1 here is -1, 2, 3, 4, -4. So I have the vertical asymptote is -2, -2, and I have also another vertical asymptote, X is 4. Here's X is 4. Okay, well, let's write this down here, 4, and here is -2. Okay, and I have X-intercept. I have X-intercept 1, set 1 and -4. I have -4 here, X-intercept, and 1. And then Y-intercept is, what did we get for Y-intercept? We get 1/2. So Y-intercept is 1/2 here. Now we get the horizontal asymptote is Y equal 1. So this is Y equal 1. Okay, and this is X equals -2, X equal 4. So I assigned here, I found X-intercept, Y-intercept, and the two horizontal, the one horizontal asymptote and the 2 vertical asymptotes. Okay, so the next step is to follow the test and then graph the function. So obviously the function, if you see here, the function has 3 parts. This number 1, number 2, and number 3. Okay, 1, 2, 3. And one last point is to see where, at what point the function crosses the horizontal asymptote. So we got this point, the last page. As the point is X equals -4/5 and Y is 1. Let's do that here, plot this point as well. This is -4/5 is a little below 1, but that must be here. So that must be, here it is. Okay. All right. So first of all, below, and this is the 2 points I have here, -4, and here is 1. So below -4, I have a positive numbers here. But at this point here, the function does not cross the horizontal line. So I have to graph this one here, like that. And after that, I have, this is positive, and this part from -4 to -2 is negative. So in this case, I would go positive here, and then I go negative right next to -2. Let's see. I go this way. This is a positive part. And then I go down. Because between -4 and -2 is negative. And then from -2 and 1 is positive. -2 and 1 is positive. But look at these 3 points here. So I'm going to make this positive until it touches a -1. But I have to go through these 3 points. So here is positive. I go from here to this point. Now, I'll go to the test again, and I'll see it's from 1 to 4 is negative. So I go here, from 1 to 4 is negative. So I go from 1, 4 is negative. Then, based on my test, from 4 to infinity is positive. So I go here, from 4 to infinity is positive. But watch something here. Although that is positive, how can I graph this? You have to graph this between, you have to graph the last part between the horizontal asymptote and the vertical asymptotes. Because vertical asymptotes, because it must be greater than 4. Horizontal asymptote, it must be more than the horizontal asymptote because of 2 reasons. Number 1, this is positive. That must be positive based on the test. Number 2, the function does not cross the horizontal asymptote at the point. So therefore, that must be in this area. How can I graph this one? I graph it this way. Okay? So this is how I graph the horizontal asymptote, vertical asymptotes, the test, X-intercept, Y-intercept, and the whole function. I hope that helps you here with this one. I'm going to give a last example, and we'll stop for today. Okay, I have this one. I have h of x equal to x squared minus 2 divided by x minus 3. Again, the first step, X-intercept and Y-intercept. So X-intercept, set the function to 0 and solve for x. And we're going to be a little faster here. So I have 2x squared minus 2 over x minus 3 equals 0. Multiply both sides by x minus 3. So I have 2x squared minus 2 equals 0. Then I have x squared, 2x squared equals 2. Divided by 2, I have x squared is 1. Therefore, I have x is plus or minus 1. So I have two x-intercepts. I have -1 and 0 and 1 and 0. For y-intercept, I set h of 0, which is going to be 2 times 0 squared minus 2 divided by 0 minus 3. So I have -2 over -3. So I got 2/3. So the y-intercept is 0 and 2/3. Now we're going to go with the vertical asymptote. I set the denominator to 0, so x minus 3 equals 0, and I got x equals 3. Horizontal asymptotes. I have the degree of p of x equals 2, and the degree of q of x is 1. Therefore, I have to use, there is no horizontal asymptote but slant asymptote. So I divide 2x squared minus 2 divided by x minus 3. So I rewrite first 2x squared plus 0, x minus 2 divided by x minus 3. Using synthetic division, as we learned before, I have my zeros is 3 here. The coefficient is 2, 0, and -2. That's why I put the 2, the 0, so we can see that the coefficient of 0. If you plug a -2 here, that wouldn't work. That would be wrong. So be careful here. You must have a coefficient for each degree of the x variable. Okay? All right, we get the 2 down. So I have 2 times 3 is 6. 6 plus 0 is 6. 6 times 3 is 18. 18 minus 2 is 16. 16 is the remainder. And here, that gives me that the slant asymptote is y equal to x plus 6. So I don't have horizontal asymptote, but slant asymptote. But no horizontal asymptote. Okay? All right, now test the slant asymptote. So we agreed that we tested before y equals 1 or y equals 0, y equals 2. So here we're going to test y equals 2x plus 6. In other words, before we set the function equals 1, we set the function equals 2. Now we're going to set the function equal 2x plus 6. So my function is 2 x squared minus 2 equal, divided by x minus 3 equals 2x plus 6. We multiply both sides by x minus 3. So for the left side, x minus 3 with x minus 3 is cancelled out. I have 2x squared minus 2. We FOIL the right side, and I would get 2x squared plus 6x minus 6x minus 18. And now 6x with negative 6x is cancelled out. So I have 2x squared minus 2 equals 2x squared minus 18. Also, if I subtract 2x squared here, 2x squared, it's cancelled out. So I got negative 2 is negative 18. And this is false. Therefore, the function h of x does not cross the slant asymptote y equal to x plus 6. All right, now the last step is to test the function. So how many points do I have here? I have, let's see, I have X-intercept, I have -1 and 1. And for the vertical asymptote, I have 3. So I have 3 points here. Now let's do that. So I have the first point plus or minus 1, and I have 3. So let's see, plus or minus 1. So let's say here is -1, here is 0, here is 1. And I have the vertical asymptote is 3. So 2 and 3. Okay. Let's plug anything before -1. Let's say h of -2. So h of -2 would be 2 times -2 squared minus 2 over -2 minus 3. So how much should I get here? 4 times 2 is 8 minus 2 or -5. So that would be 6 over -5, which is negative. So here I have negative. Okay, the second part, between -1 and 1, I obviously get 0. 2, 0 squared, minus 2, over 0 minus 3. So I have -2 over -3, which is 2/3 positive. So here is positive. From 1 to 3, I will get h of 2. And what should I get here? 2 times 2 squared minus 2 divided by 2 minus 3. So I'll get 4. 2 squared is 4 times 2 is 8 minus 2 divided by 2 minus 3 is -1, which is negative. The last thing I get h. So I have negative here first. H of 4, something greater than 3. So 2 times 4 squared minus 2 divided by 4 minus 3. So 4 squared is 16 times 2 is 32 minus 2 is 30, and 4 minus 1 is 1. Minus 3 is 1, excuse me. So this is positive. So here is positive. Okay. So let's graph the function. So what do I know about the function so far? I know that the function, there is a vertical asymptote and slant asymptote. The function doesn't cross the slant asymptote. And the function has 2 X-intercept and 1 Y-intercept. So first of all, we graph the coordinates. And we plug x-axis, we plug x-intercepts. So for this one, I have x-intercept is plus or minus -1. So I have -1 here, -1, and I have 1. And I plug the vertical asymptote. I have vertical asymptote at 3. So 1, 2, oops, and 3. So here is the vertical asymptote. Now I have slant asymptote. My slant asymptote is 2x plus 6. So 2x plus 6. To graph that, I go to 6 here. 1, 2, 3, 4, 5. Maybe I need more here. And then here's 1, 1, 2, 3, 4, 5, 6. Let's make it half. 1, 2, 3, 4, 5, 6. And then 2x plus 6. I want to get X-intercept and Y-intercept. So X-intercept, I set that to 0, so negative 6 over 2, so that would be by negative 3. 2, and negative 3 here. And that should be the slant asymptote should be this way. Oops. Ooh. Okay. I ran out of space, so I'm gonna remove that. Okay. And then I go with X-intercept here. And here is, sometimes it's hard to set the dimensions. So the scale, sometimes it gets hard. So now I didn't graph the slant asymptote, so I ran out of dimension. Maybe I would do it better after that. Okay, so now one more thing I didn't write is Y-intercept. So what is Y-intercept here? I got Y-intercept equal 2/3. So 2/3, I go with 2/3 here, maybe a little, oops, 2/3. Excuse me, 2/3, so that would be here. This is Y-intercept. Okay, so I have X-intercept, Y-intercept, X-intercept. I have 2 X-intercept. I have 1 Y-intercept, and I have 1 vertical asymptote, 1 slant asymptote. Okay, I don't have horizontal asymptote. And the function does not cross the slant asymptote. Okay, so the first thing is to test the vertical, the positive and the negative. So for this part here, I have here this part, the greater than 3 is positive. So here positive and does not touch the slant asymptote. So in this way, I'm going to graph the function between 3 and the slant asymptote here. So that must be this way. Okay. Next, what happens between 3 and 1? 3 and 1 is negative. So 3 and 1 is negative. And so that should be here negative. Okay. And between 1 and negative 1 is positive. So if it's positive, that must be this way. And remember that we have Y-intercept at 2/3. So I have to make a positive curve that passes through 2/3. Make it this way. Okay. And the last thing is from -1 to the rest must be negative. I'm going to make this way, close to the slant asymptote. And this is how I graph the function. This is one of the tedious function that we have learned. It's more tedious actually here, but this is how it looks like. Well, I hope that helps you. Again, we have 5 steps to get the function, the rational functions graphed. Number 1, set X-intercept and Y-intercept. Find the vertical asymptote, horizontal asymptote, or slant asymptote. Figure out whether the function cross or doesn't cross the slant or horizontal asymptote. Test the interval, and then finally you graph the function based on these graphs, these information. I hope that helps today. That's by the end of today. It's the end of the lecture. I know it's a long lecture, but it's one of the most tedious lectures. So if you have any question, please let me know. Email me or set a session with me one-to-one, and we can work on that. Okay, thank you and have a great day.